So AST is formed from your code that you write, and then it goes to ignition interpreter. Most of the code, right? And a lot of code, it just interprets it and it runs line by line. It is converted to bytecode and then finally executed. Bytecode and execution. But what happens is there is some portion of code which is reused, which is used a lot, and there are chances of optimization. So what it does is that code is given to Turbofan compiler, and then with Turbofan compiler, optimized machine code is built. Right? Optimized machine code is built, and then finally that optimized machine code is executed. Got it? Now this is how things work. This process is known as optimization also, right? This process is known as optimization also, right? Let me just use some other color to represent the name of that process. Okay, let me use a black color. This is also known as optimization, right? This portion is known as optimization. Now, let me just tell you, suppose if there's a function which you are calling again and again, what it will do is JavaScript will see that, okay, there is chance that I can improve it. I can compile that code and convert it to machine code so that it runs very fast again, right? And so that way your code is executed even faster, right? So basically the major drawback of interpreter was that it was not able to execute the code that fast. But now suppose there are portions of code that needs to be executed that fast and these are being executed again and again. It offloads that to Turbofan compiler, and then compiler actually optimize that code, and then that machine code is read. Now, while in this process, there are chances that you might have to de-optimize the code also. What do you mean by de-optimization? Now listen to me very carefully. What happens is sometimes your code is also de-optimized, right? De-optimized. What do you mean by de-optimized? So this de-optimization is, now let me take an example and show it to you. It's a very tricky concept to explain, right? So suppose in JavaScript, suppose you have a, let me just give you an example. Listen to me very carefully, otherwise you won't understand. Suppose you have a function sum, and that function sum takes a and b, and it calculates the sum of two numbers, right? Returns sum of two numbers, right? And this sum function is called again and again, it is called again and again. Now JavaScript sees that, okay, this function is a very hot piece of code, this function. Now Turbofan compiler will take that sum function and it will optimize it. But while optimizing the code, Turbofan makes assumptions. How? I'll tell you. Makes assumptions. Suppose you call the sum function with 10, 5. Suppose you call this sum function with two parameters, 10 and 5. So what happens is Turbofan compiler will assume that the value of a and b will be numbers, and it will optimize the code. So next time you make a call, suppose you make a call to sum 2, 3. So what happens is this will be running very fast, right? This code will be compiled, right? This code will run very fast. Suppose if you call the sum once again, with the numbers maybe 6, 7. So what happens is that this code will also run very fast. Now suppose you call this sum function. Now this time you did not pass it two integers. Now suppose you did not pass it two numbers, but you passed two strings, because in JavaScript you can do anything, right? If it is a sum function, you can pass it two numbers, you can pass it two strings, you can even pass a function inside a function, right? So what happens is, suppose you passed in two alphabets. Suppose I say, okay, sum of a and b. Okay, so basically when you sum two strings over here, so it basically concatenates the two string, right? Suppose you do a sum of a and b, so it will make ab, right? This is how it will happen. So suppose if you do this, now here the optimization fails, because Turbofan has compiled your sum function to be executed for two numbers. But now it is not seeing a number, it is seeing two strings. So what it says that, okay, whatever the code that I optimized is not correct, because I was expecting an integer, I was expecting a number, but what came in? Strings came in. So what it will do, it will de-optimize the code, and then the ignition interpreter will again call the sum function a and b with two strings, and it will convert it to bytecode and will do execution. So do you understand that or not? Okay, let me just explain you once again. So what happens is, suppose there is a sum function, okay? Suppose there is a sum function a, b. Now what happens is, this calculates the sum of a and b, okay? This calculates the sum of a and b, okay? Now suppose if you gave sum of 10, 7, okay, so this code will run. Suppose if you wrote sum of 7, 6, you passed in two integers again. So what it will do, the ignition interpreter will recognize that, okay, this sum function is being called again and again. That means we can optimize it so that next time it runs, it will be very fast. So the Turbofan compiler tries to compile that code and optimize it. But while making an optimized version of that code, it makes some assumptions. And those assumptions are that, okay, these two values will be numbers. So it generally makes the assumption of the types. So suppose it says that, okay, some function will also take two numbers, right? But if you will keep passing in numbers over here, if you will keep calling this to these two statements, right? So it will execute very fast. But as soon as you start passing in some other things, suppose if you start passing in objects, where the Turbofan compiler was expecting numbers. So what will happen now? The code will be de-optimized. So JavaScript engine is like recognizes that okay, now the code that I optimized will not work for some function anymore. I need to de-optimize it. Basically, the turbofan compiler will say I cannot send the request to optimize machine code because this will not work because there are no numbers out there, right? So it will again de-optimize the code. Now ignition interpreter will again interpret it like how it used to do, and it will take that and it will convert to the bytecode and execute it. So while the code is running, a lot of things are happening. So ignition interpreter is interpreting your code again and again. It is just checking whatever codes can be optimized. That hot code is passed to turbofan compiler. Now turbofan compiler is making a machine optimized code. Machine optimized code is then executed. In the ignition interpreter is also executing the code. Now if suppose some code it needs to be de-optimized, it de-optimizes also. And when it de-optimizes, then ignition interpreter again converts it to bytecode and executes it. So all these things are happening in parallel. All these things are happening in parallel, my dear friends. And meanwhile, there are a lot more things happening, right? There is one more thing which is known as inline caching. Read it up, right? I am not explaining everything because it becomes very tough for me also. There is something known as inline caching, okay? There is something known as inline caching, okay? So it caches things up, and then there is something known as copy elision. So there are a lot more things, caching, right? Inline caching, copy elision, all these things are happening behind the scenes inside this ignition interpreter, compiler, and all these things, right? And this whole thing, what you see over here, is known as just-in-time compilation. Okay, this whole thing is known as just-in-time compilation. Basically, the use of compiler plus interpreter to convert the code to bytecode and machine code and then finally executing it. The whole process is known as this whole process is known as just-in-time compilation. So you understood, right? JavaScript is neither an interpreted language, neither a compiled language. It uses interpreter as well as a compiler. It uses the power of both, right? That is why you see, right? As soon as you give JavaScript to V8 engine, it just quickly executes it. How? How does it quickly execute it? Because of ignition interpreter. Right? Interpreter starts reading the code line by line very fast, right? Now, as soon as it sees the opportunity to optimize, it passes that code to turbofan compiler. Turbofan compiler then optimizes the machine code and then it optimizes it, right? Now, next time that code is executed, it executes very fast. Very fast it is executed. Isn't it amazing? Right? The power of interpreter plus the power of compiler. Now, suppose if the turbofan compiler sees something unexpected, then it de-optimizes the code also. Think about the beauty inside V8 engine. Somebody has written a code to do all these things. Somebody has written code to implement whatever. I am showing it to you in the diagram. It looks easy, but it is not easy, my dear friends. It's a very, 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 very complex thing. It's a very complex thing. Inside, internally, I have not even explained you, right? If you go inside, then you will see that, okay, there are a lot more level of complexities involved. I have just given you a very easy example of a sum function over here, right? So what do you see as a developer is, suppose if you are building a function, then never, suppose if you are passing two integers, so always pass the expected things. Always pass expected things. Suppose if you have a function, sometimes you pass in integers, sometimes you pass in strings, sometimes you pass it something else. So what happens is it takes a tough time. It is a tough time for a compiler. You understood, right? Now as a developer, if you create a sum function, you should only pass numbers if you want to pass numbers. Don't pass strings over there. If you start passing in strings, then what will happen? The compiler will have to de-optimize the code. Optimize it, de-optimize it, and it will take more time than it is expected. Now, let me just recap everything once again in another diagram. Let me make everything once again, right? So let me just summarize everything. Suppose you have this code, okay? So you have a code over here and you pass this code to V8 engine. So the first thing happens is what? You know, right? Parsing. Parsing happens, and inside the parsing, it is broken down into tokens, right? It is broken down into tokens, and then after tokens, what happens is there is a AST generated, isn't it? Do you remember? So the output of parsing phase is AST. Now this AST is then passed to your ignition interpreter. Ignition interpreter, right? And what does this ignition interpreter will do? This ignition interpreter will convert this code to your bytecode, isn't it? Bytecode, which is finally executed. This is execution. Okay, bytecode is finally executed. Now what happens is, in between of this ignition interpreter, if it finds the opportunity to optimize the code, what will it do? It will pass that to turbofan compiler. Turbofan compiler. This step is over here known as optimization. Okay, and now what will turbofan compiler do? Turbofan compiler will compile this code and convert it to optimized machine code. Optimized machine code. What will happen to optimized machine code? It is finally executed. Now there is one more step involved which is known as de-optimization, right? This step is known as de-optimization. Let me use some other color pen to highlight it. This is known as optimization. I am trying to make my diagram beautiful, and this is known as de-optimization. Okay, all these things are happening. Now over here de-optimization happens, and once the de-optimization happens, right? Once the de-optimization happens, what happens is ignition interpreter again converts it to bytecode, and then the code is executed. Now all this is happening behind the scenes, right? Now V8 engine also is doing one more important job, and that job is known as garbage collection. Do you know that? Do you remember? There is one more job of V8 engine that is known as garbage collection, right? So there is a garbage collector, there is a garbage collection. This is a parallel job, right? There is a garbage collector, garbage collection. Okay, let me just make it a little more beautiful in the diagram so that, okay, so this is garbage collection that is happening simultaneously, my dear friends. This garbage collection is happening simultaneously over here along with running the code, right? Ignition interpreter, turbofan compiler, and garbage collection is happening in parallel by V8 engine. Now there are different type of garbage collection, which are garbage collectors, which are there in Chrome's V8 engine. The first one is known as Orinoco. Okay, so I told you, right, V8 engine has cool names of things. So just like it has ignition interpreter, turbofan compiler, so the garbage collector is known as Orinoco. There is one more garbage collector, right? Its name is oil pan. Okay, let me just write it properly. Okay, so let me make garbage collection even better. Sorry for my bad handwriting. Garbage collection. Okay, and now the garbage collector first is Orinoco, Orinoco. Orinoco. There is one more garbage collector which is known as oil fan, right? Oil pan. One is known as scavenger, right? And there is something known as, I don't remember the name actually, Mark Compact or MC something, right? MC garbage collector, right? Compact, some Mark Compact, I think, right? So these are the things which are happening inside garbage collection. This garbage collection is happening behind the scenes. There is an algorithm. There is known as mark and sweep algorithm. Right? Mark and sweep algorithm, which is running behind the scenes. There are so many things that happen V8 engine. Inside V8 engine, there is parsing going on, there is AST being converted, there is ignition interpreter, there is bytecode which is being generated, then it is executed. There is a optimization and de-optimization happening inside the turbofan compiler. And trust me, I love the names. This is ignition interpreter, there is turbofan compiler, there is Orinoco, oil fan, scavenger, something Mark Compact or something, I don't remember the name exactly, but there are different type of garbage collectors which are present over there. They are doing their own job. There is a different job of Orinoco, there is a different job of oil pan. There are new memory spaces which are being vacant, there are old memory spaces which are being cleared, and a lot of things are happening in garbage collection methods. There are different types of algorithms also. This is mark and sweep algorithm. There are more algorithms out there. Even while interpreting and compiling the code, there are caching happening. And if you will see how this code is compiled, then it's again a very big concept in itself. But in this video, my dear friends, my major motive was to make you curious, make you understand that how beautiful V8 engine is. The code that you write where a is equals to 10, a lot of things are happening behind the scenes. Lot of things. That code is broken down into tokens, then those tokens are converted to AST, that AST goes to the interpreter converts it to bytecode, then bytecode is then executed. So many things are happening, and in between compiler is happening, in between garbage collection is happening. Whenever you run the code, there are so many things that your computer is doing, and it is doing everything in just fraction of seconds. Just doing it in fraction of seconds. That is why I just love JavaScript. I love how V8 engine works. It's very, very beautiful. Very beautiful, my dear friends. Read more about inline caching, how it happens, copy elision. Read more about all these jargons that I told you, right? All these things are very amazing and unique in themselves. This is how the whole V8 engine works, my dear friends. This is how the whole V8 engine works.